Hello guys, let's talk about shortest seek time first SSTF scheduling algorithm. In this algorithm, the request which is closest to the current head position will be serviced next. Assume that the stream of track access requests are 105, 45, 74, 68, 87, 90, 28, and 55. And there are total of 110 tracks, numbered 0, the outermost track, to 109, the innermost track. The read and write head is currently servicing a request for the track 65, and all the requests that we example above had a prior to its completion. Remember, in shortest seek time first SSTF schedule algorithm, we must find the shortest to the closest current head position. In here, since track 68 is the nearest to track 65, it will be serviced next. Let's just make an illustration. 65, and let's assume that 68 is in this position. Let's copy this and paste it here and label it 65. 68, my bad. Since the current head is at 68, let's now find the nearest request to the current head, which is 74. Let's just cross this out. Now 74, copy, paste. Let's assume that 74 is in this place. 74. Copy, paste. Let's go 74. The current head is 74. So the nearest track to 74 is 87. Let's cross this out. Assume that 87 is in this position. 87. The current head is now at 87, and the nearest track will be 90. And we can see that 90 is just over here. Let's just align it. That's where you can find 90. Oh, I think I have some problem here. Control B. Where is the thing? Copy, paste, and move. Let's just label it 90. I think we have some problem here. Copy this one and paste it. Okay, let's go. Let's discuss again. The track 90 is nearest to the 80. Track 90. Okay. The current head is now at 90, and the nearest track from 90 is 105. Copy this one, paste. Let's now move to 105. Let's label it 105. And in here, we can see that all of the higher tracks are now eliminated. So the remaining tracks are 45, 34, 28, and 55. We all know that 55 is the nearest track in since track 55 is the nearest in track 105. It will be service next. Track 55, 105 to 55. Just like that in that position. Track 55. Let's now eliminate track 55. The remaining tracks are 45, 34, and 28. 45 is the nearest track in 55, so it will be service next. 45. You can see that 45 is just over here. Yes, just like that. 45. 45. Track 45 is now done. The remaining tracks are 34 and 28. Since track 34 is the nearest track up in 45, it will be service next. 34. Let's eliminate 34 and illustrate that track 34. Assume that 34 is in this place approximately. Thirty-four. And last track is 28. Control. Assume that 28 is in this track. 28. Okay. We are now done tracking the request. Let's now trace how many tracks each currently head gain. So from track, from, let's just bold it, from, control D, from track 65 to 68, 65 to 68, we can now know the tracks if we minus 68 to 65. So the total tracks is 3. From track 68 to 74, 74 minus 68. The total tracks will be 6 from track 74 to 87. The total tracks will be 13. From track 87 to 90, the total tracks will be 3. From track 90 to 105, as you can see, the current head is at 90 and go to 105. The total track is 105 minus 90 is equals to 15 tracks. From track 105 to the current head is at 105. From 105 to 55, the total tracks will be 50 tracks. From track 55 to 45, the total track will be 10 tracks. From track 45 to 34, 45 minus 34, the total track will be 9 tracks. From track 34 to 28, the last track, 28, 34 minus 28, the total track will be 6 tracks. So let's just sum up the total tracks and know the total number of read and write. Total number of read and write. 3 plus 6 plus 13 plus 3 plus 15 plus 50 plus 10 plus 9 plus 6 is equals to 115 tracks. And that's it. There are 115 tracks in this one. Compared to FCFS algorithm, it has a better performance in terms of minimizing the head movement. And that's the shortest seek time per algorithm. I hope you learned something.